This is a quick video on how to fill in your unit circle with the information for these 16 points. You need both the radians, the degrees, as well as coordinate points. Now, we're not going to do coordinate points next to the points. We're going to be doing the coordinate points that are on the axes, this horizontal axis and this vertical axis. And we are learning that this horizontal axis, while we think of it as the x-axis, we also now will be referring to this as the cosine axes. And the y-axis, we will now be referring to as the sine axis, because the numbers on this axis will be the values of sine for any of these angles, and the numbers on this cosine axis will be the cosine values for any of these 16 points, or any points on the unit circle. So, first of all, let's look at the unit circle. The unit circle has a radius, and we call that one radius, and that is an object, that is the radius. We're going to turn that into a unit of measure. Just like we have inches and feet and everything else, we're going to have these units of measure where this is the length of one of those units of measure, and the unit of measure is called a radian. And we take this length and we lay it on the outside of the circle, and there it is, that one radian, not radius, one radian, because it's a unit of measure. And we can keep laying a unit of one radian around here. And we say there's one is right here, and two would take us to there, and three would, oh, it didn't go halfway around the circle. There's a little bit left over. How much is left over? Well, a fraction, a very small piece, the piece of 0.14159265355, which is, as we can imagine, that is the little bit that makes it halfway around the circle is pi radians. That's what the number pi means, is when you go the length, the number of radiuses or radii that it takes to go halfway around the circle, that length, is pi radii. And we say radians. Now, if I take this, I'm not going to talk about the bottom half because I'm going to leave that for you to do in the unit circle, but we're going to work on this top half here. If I take just this top half of the circle and I divide it into equal slices, and I made 6 slices, so each of those slices is 1/6 of the way halfway around the circle, which means this length right here is 1/6 of pi, which I say, oh, then that point on the circle is where that radial length is 1/6 pi. And we go around and we say, oh, we have 2/6 and 3/6 and 4/6 and 5/6 and 6/6 of pi. But 6/6 of pi is just pi. And then also these three up here, 2/6, 3/6, and 4/6, they all reduce. So I'm going to write those in reduced fractions, 1/3, 1/2, and 2/3. And while those represent the radial length, we also call those the angle of rotation. So if I'm standing in the center of the circle, I rotated 1/6 of pi to look down that spoke. Now you might say, I don't usually see them written this way. That's I'm showing you why those numbers come from that we get in the unit circle, because we're looking at even distributions, even slices of this circle. So usually you see them written like this: pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and then pi. And again, you're going to finish the rest of it. You're going to figure out what the other ones are down here. Now, I've left these ones out because they were not part of those 6 slices. What's this dot here and this other dot here about? Well, that's if I sliced the top half into 4 equal pieces. And so this would be 1/4 and 2/4 and 3/4 and 4/4 of pi. And again, 2/4, well, that just reduces to pi over 2. And then these other ones, instead of writing it as 1/4 pi and 3/4 pi, we typically see it written as pi over 4 and 3 pi over 4. But it is just that fraction of pi. Now again, you need to finish the rest of the circle with the radians on the outside. But I want to look now at what happens when you connect straight across, so perpendicular to the y-axis. I'm going to do a segment from 5 pi over 6 over to pi over 6, and another segment from 3 pi over 4 to pi over 4, and another one here, and we have those segments. You don't need to draw them in your unit circle, just look at this. What you need to draw in your unit circle are where these lines intersected with this vertical axis, and there's 3 points. And so figuring out the sine values is as easy as 1, 2, 3. We have 3 points. And this first point is 1/2. And the second one, this is 1, 2, 3. This one is not 2/2, but root 2/2. And then the next one is root 3/2. So it's 1, 2, 3, but they're square roots. So it is actually square root of 1, but square root of 1 is 1. So 1, 2, 3, square root of 1, square root of 2, square root of 3, all divided by 2. We're going to do the same thing, but we're going to do it vertically. And so it's going to be perpendicular to what we think of as the x-axis, but we're now calling the cosine axes. And we do those lines. And again, I don't need you to draw the lines. Don't draw the lines. Just draw. You're going to hold a ruler from one point to the other. And then put a dot on the axes. There's 3 of them, those intersections. And again, 1, 2, 3. 1/2, root 2/2, root 3/2. These are the sine values for these angles. So when I go straight over from pi over 6, the sine of pi over 6 is 1/2. The cosine of the sine of pi over 4 is root 2 over 2. The sine of pi over 3 is root 3 over 2. These are the cosines, and so I can talk about the cosine of pi over 6 goes straight down is root 3 over 2. The cosine of pi over 4 is root 2 over 2, and the cosine of pi over 3 is 1/2. You need to fill out all the numbers that go on these parts of the axis, as well as these radians down here in the lower half of the circle. Not only, though, do you need to have radians and these coordinate points, but you also have to have the degrees. Now, remember when we cut it into 6 equal slices? Well, it's 180 degrees to go halfway around a circle. So when you cut that into 6 slices, you're counting by 30s. So it's 30 degrees, 60 degrees, 90 degrees, 120, 150, and 180. The other ones were when we did 1/4 of 180. So 1/4 of 180 right here is 45. That is 1/4 of 180. And then this is half of 180. And then right here, this dot that's missing is 3/4 of 180, also known as 135. You also can see that, you add 15. 30 plus 15 is 45. Over here, 120 plus 15 is 135. You need to finish writing all of your degrees on the inside of the circle for those dots. So in the end, you're going to have the radians, the degrees, and those coordinate points on your unit circle.